ಆತ್ಮೀಯ ವಿದ್ಯಾರ್ಥಿಗಳೇ, ತಾವೆಲ್ಲ ದ್ವಿತೀಯ PUC ಶೈಕ್ಷಣಿಕ ವರ್ಷದ ಮೊದಲ ಹಂತದ ಪರೀಕ್ಷೆಯನ್ನು ಮುಗಿಸಿ ಎರಡನೇ ಹಂತದ ಪರೀಕ್ಷೆ ಸ್ಪರ್ಧಾತ್ಮಕ ಪರೀಕ್ಷೆಗಳ ತಯಾರಿಯನ್ನು ಮಾಡ್ತಾ ಇದ್ದೀರಾ. ಈ ಪರೀಕ್ಷೆಗೆ ಸಂಬಂಧಪಟ್ಟಂತೆ ನಾನು ಬೆಳಗಾವಿಯ ಡಾಕ್ಟರ್ CN ನಾಯ್ಕರ್ ಕೆಲವು ರಸಾಯನಶಾಸ್ತ್ರ ವಿಷಯಗಳಿಗೆ ಸಂಬಂಧಪಟ್ಟಂತೆ ಬರಲಿರುವ CET ಮತ್ತು ನೀಟ್ ಪರೀಕ್ಷೆಯ ಚರ್ಚೆಯನ್ನು ನಿಮ್ಮ ಜೊತೆಗೆ ಮಾತನಾಡ್ತಾ ಇದ್ದೇನೆ. ಮೊದಲನೆಯ ಚರ್ಚೆ ಹ್ಯಾಲೋ ಅಲ್ಕೇನ್ಸ್ ಮತ್ತು ಹ್ಯಾಲೋ ಅರೀನ್ಸ್ ಮೇಲೆ. ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್, this unit, haloalkanes and haloarenes, has a weightage of about 3 questions in the CET examinations and about 2 questions in NEET examination. On this unit, haloalkanes and haloarenes, first we'll have a synopsis of haloalkanes. We know that haloalkanes are halogen derivatives of alkanes. In these, one or more hydrogen atoms of the alkanes are replaced by halogen atoms. Depending on the number of halogen atoms present, we have classification of haloalkanes into different types as monohalogen compounds, dihalogen compounds, and polyhalogen compounds. In monohalogen compounds, there is a replacement of one hydrogen atom by a halogen atom. In dihalogen compounds, there is a replacement of 2 hydrogen atoms by halogen atoms, while in polyhalogen compounds, there is a replacement of more than 2 hydrogen atoms by halogen atoms. Monohalogen compounds are further classified as primary, secondary, and tertiary halogen compounds depending on the position of the halogen atom. If the halogen atom is attached to primary carbon atom, it's primary halogen compound. Similarly, we have halogen atom attached to secondary carbon atom, which is secondary halogen compound, and a halogen atom attached to tertiary carbon atom, which is a tertiary halogen compound. Dihalogen compounds are further classified as weak dihalides or vicinal compounds and gem dihalides or geminal compounds. The difference between these two compounds is the 2 halogen atoms are present on adjacent carbon atoms in vicinal dihalides, while they are on the same carbon atom in geminal dihalides. In polyhalogen compounds, we have replacement of more than 2 hydrogen atoms by halogen atoms. If you look at the examples here, ethyl bromide is a primary alkyl halide, isopropyl chloride is a secondary alkyl halide, tertiary butyl chloride is a tertiary alkyl halide. Here 1,2-dichloroethane is a vicinal dihalide, 1,1-dichloroethane is a geminal dihalide, while the haloforms like chloroform, bromoform, iodoform, and carbon tetrachloride are polyhalogen compounds. Now we will have a quick review of methods of preparation of haloalkanes. One of the most important method for preparation of haloalkanes is from alcohols. In this method, alcohols are converted into haloalkanes by the reaction with hydrogen halide in presence of anhydrous zinc chloride, or by the reaction with phosphorus halides like PX3 and PX5, or by the reaction with thionyl chloride in presence of pyridine catalyst. Another important method is halogen exchange method, wherein the Finkelstein reaction involves preparation of alkyl iodide and Schwartz reaction involves preparation of alkyl fluoride. In Finkelstein reaction, alkyl chloride or bromide reacts with sodium iodide to give alkyl iodide, while in Schwartz reaction, alkyl halide like alkyl chloride or alkyl bromide reacts with metal fluorides like silver fluoride to form alkyl fluoride. Now we will come to the brief synopsis of haloarenes. Haloarenes are halogen derivatives of aromatic hydrocarbons. The main difference between haloarenes and haloalkanes is in haloalkanes, the halogen atom is attached to sp3 hybridized carbon, while in haloarenes, the halogen atom is attached to sp2 hybridized carbon. In haloarenes, we have further classification as monohalogen compounds, dihalogen compounds and polyhalogen compounds. In monohalogen compounds, only one halogen atom is present in the aromatic hydrocarbon, this is chlorobenzene. In dihalogen compounds, the two hydrogen atoms from the aromatic hydrocarbon are replaced by halogen atoms. This is orthodichlorobenzene or 1,2-dichlorobenzene, which is a dihalogen compound. In polyhalogen compound, we have 3 hydrogen atoms or more than 3 hydrogen atoms replaced by halogen atoms. So, this is 1,2,3-trichlorobenzene, which is a polyhalogen compound. So, now we will have a quick review of methods of preparation of haloarenes. One of the important methods for preparation of haloarenes is from arenes, the aromatic compounds like benzene, by halogenation. Say for example, when benzene reacts with chlorine in presence of ferric chloride, it gives chlorobenzene. So, instead of using chlorine, if we use bromine, you will get bromobenzene. Then another important method is preparation of haloarenes from diazonium salts. First, we get the diazonium salts from aniline. When aniline reacts with nitrous acid at 0 to 5 degrees Celsius, we get diazonium salts like benzene diazonium chloride. This benzene diazonium chloride is then converted into haloarenes by Sandmeyer's reaction. Say for example, benzene diazonium chloride on reaction with cuprous chloride in HCl gives chlorobenzene. If it reacts with cuprous bromide in HBr, it gives bromobenzene. Then Hunsaker reaction and Balz-Hiemann reaction are another two methods for preparation of haloarenes. In Hunsaker reaction, silver benzoate reacts with bromine in carbon tetrachloride to give bromobenzene. So, in Balz-Hiemann reaction, we have diazonium salt reacting with HbF4 to give fluorobenzene. So, this is how chlorobenzene, bromobenzene and fluorobenzene, the haloarenes are obtained by different methods like arenes, diazonium salts, Hunsaker reaction, Balz-Hiemann reaction, etc. Dear students, based on the synopsis what we had discussed so far and also whatever the knowledge we have on haloalkanes and haloarenes, let us look at some of the questions related to this unit. Now, we will have the first question on this unit. The question goes like this: the strong nucleophile and the best leaving group in the following reaction are respectively. The reaction is CH3X plus nucleophile giving CH3NU plus X minus. The options given are phenoxide ion and chloride ion, OH minus and Br minus, acetate ion and F minus, CH3O minus and I minus. When we read this question carefully, we will get an idea about the answer here. Look at this. The strong nucleophile means the most reactive nucleophile, and also the strong leaving group, I mean the strong halide ion. The strong nucleophile and strong halide ion are to be identified here. For a strong nucleophile, we should find the nucleophile which is least stable. The least stable nucleophile is most reactive. Look at the options given here. Phenoxide ion and acetate ion. In option A and C, we have phenoxide ion and acetate ion. Based on the study of phenols and also the study of carboxylic acids, we know that phenoxide ion and acetate ion are stabilized by resonance. Due to the stability of these ions, they may not be the strong nucleophiles. So, options A and C are ruled out. Now, coming to the options B and D. Here we have OH minus and CH3O minus. Out of the two nucleophiles here, due to inductive effect of the CH3 group on this oxygen, the charge density on this oxygen is increased. When the charge density is increased, stability is decreased or reactivity is increased. So, therefore, CH3O minus due to inductive effect is least stable or most reactive, or it is a strong nucleophile. With this, automatically we get the I minus also. And even amongst the alkyl halides, alkyl iodides are more reactive than alkyl bromides. Alkyl bromides are more reactive than alkyl chlorides, and alkyl chlorides are more reactive than alkyl fluorides. So, on that basis, the best leaving group is I minus and the most strong nucleophile is CH3O minus. So, the correct option for this question is option D. Now, we will move to the second question. The question is, silver benzoate reacts with bromine to form benzene, option B bromobenzene, option C benzoyl bromide, option D benzoic acid. Just now in the synopsis we had seen that one of the methods for preparation of haloarenes is Hunsdiecker reaction, wherein silver benzoate reacts with bromine in carbon tetrachloride to give bromobenzene. So, according to this reaction, the correct option, the correct product in this reaction is option B bromobenzene. Dear students, the questions in the competitive examinations are mainly based on application of the knowledge. Very few questions are based on the memory, but most of the questions are based on the application of the knowledge what we have on that particular area. Let us take the next question as an example for this. The question is, an unknown alkyl halide A reacts with alcoholic KOH to produce C4H8, which on ozonolysis gives 1 mole of propanone and 1 mole of formaldehyde. The structure of A is option A, tertiary butyl bromide, 1,2-dibromobutane, 2-bromobutane, 1,4-dibromobutane. Look at this question. When you read the question carefully, you will get an idea about the first part of this question. The alkyl halide A reacts with alcoholic KOH. Just now we had a discussion on properties of haloalkanes. Alcoholic KOH is a reagent for dehydrohalogenation. When alkyl halide reacts with alcoholic KOH, it undergoes dehydrohalogenation to form an alkene. So, C4H8 formed in the reaction must be an alkene. And the second part of this question is related to aldehydes and ketones. We know that aldehydes and ketones are obtained by ozonolysis of alkenes. We have an alkene here. This alkene undergoes ozonolysis. Look at the products of the ozonolysis. 1 mole of propanone and 1 mole of formaldehyde. So, one part has 3 carbon atoms and the other part has only 1 carbon atom. Since the alkene is C4H8, all the options which we have are containing 4 carbon atoms. But to select the correct option, first think of dehydrohalogenation followed by ozonolysis to get aldehydes and ketones. Let us restrict to the first option. If this is heated with alcoholic KOH, this H and this Br, they get eliminated as HBr and an alkene is formed here. This alkene on ozonolysis, first it reacts with ozone to form an ozonide. That ozonide on hydrolysis in presence of zinc gives this part as one product and this part as the other product. The products are aldehydes and ketones. So, this will be CH3COCH3 and other one will be HCHO. Acetone and formaldehyde are obtained from this, or propanone and formaldehyde are obtained with option A. If you come to the option B, suppose if this is heated with alcoholic KOH, this H and this Br they get eliminated, it forms an alkene, and this H and this Br again they get eliminated, this forms an alkyne, but here we have an alkene. So, option B is not suitable. When you come to the option C, here when this H and this Br they get eliminated, we get butene here. If this butene is subjected to ozonolysis, the products are 2 moles of acetaldehyde, but here we have 1 mole of propanone and 1 mole of formaldehyde. On the other hand, if you take the last option, here this H and this Br gets eliminated and we get double bond here, and this H and this Br it gets eliminated and this forms a double bond here, and this does not give the required product. So, the required product, one part should give formaldehyde other part should give propanone or acetone. So, accordingly, option A, tertiary butyl bromide or 2-methyl 2-bromopropane on reaction with alcoholic KOH followed by ozonolysis gives propanone and formaldehyde. So, accordingly, the correct option for this question is option A.